This video is looking at the required practical from the topic B7, ecology, and it's a one of two videos looking at sampling techniques. This one is looking at quadrat sampling. We use quadrat sampling when we have a regular area, okay, so it's an area that's uniform, similar across the whole area, and we can use the techniques to estimate plant population numbers, or now also looking at percentage cover, okay. And it's an area that's too large to count everything, so we need to use a sampling technique. So the equipment I need for quadrat sampling is a trundle wheel, a quadrat. This quadrat has 100 squares on it, so that helps for percentage cover, and it's 1/2 metre by 1/2 metre. I've also got my plant key, which has got lots of information about the kind of plants I'm going to see on a school playing field. And I've got a results table as well, okay, and you can see here I've set up my results table where I can add different plant species in there depending on what I find when I go out there. And we're looking at doing 10 quadrats, okay, because it's such a vast area. Doing 3 isn't going to give me very reliable results, okay, so I need to repeat the experiment many times. If I repeat it myself, I can call the experiment repeatable. If I collate my information with other people and I use their data, I can call my data reproducible, okay, and I have to be able to get the same pattern of results across that data, okay, and repeating it lots of times means that I have reliable data, and that's what I'm looking for, reliable data. So I'm going to collect lots of information from those quadrats, okay, throw the quadrat down, look at what species are in there, and either do percentage cover using the quadrat, each square representing 1%, or I'm going to count in individual species. And then I can work out a mean average by adding the results for, say, all of the clover and then dividing by 10. And then I'll talk about how I get the estimate shortly. You can see on this result sheet as well, I've got length of field, width of field, area of field. Okay, I'm going to talk about that next. The first thing I'm going to do with my trundle wheel is go out to the field and measure the length and the width of the field. Now I'm quite lucky because the field I've used is a rectangle. If you had an L-shaped field, you'd have to split it into 2 sections to work out the area. But I've walked along it with the trundle wheel, and it's 278 metres in length and 168 metres in width. So if I multiply those together, I can get the area of the field, and you can see it's 46,704 metres squared. So I worked that out on my calculator to make sure I got my results correct, and I've put it into my table. Now, as you can see, it says here that placement of the quadrat must be random, okay? We don't want any bias. Let's say we have our field and we're trying to prove that there's a lot of a plant out there that is an endangered species. And if we see that there's a lot of that endangered plant species in one area and we just keep putting our quadrat down there, it's actually going to be a very biased set of results, okay? So we need to make sure it's random so that we are not trying to use our own opinions to affect where we put that quadrat. One way we can do that, and the exam board are happy for us to write, is that we just lightly frisbee the quadrat into position so that it lands somewhere random. Alternatively, if I start here, I've just walked out to the field and I've randomly stood in any area, and then I roll a dice and the dice rolls a 2, I can walk 1, 2 paces and then roll again, and maybe it rolls a 1 and I walk 1 pace, and then I can randomly put my quadrat down there, okay? So the dice has decided how far I'm going to walk and where I'm going to put my quadrat down. And then, because it's a big field, I might come over here and do the same process, either frisbee the quadrat or do my grid references and walk out. And I've got to make sure I'm covering the whole field doing my 10 quadrats, okay? So it must be a random distribution of the quadrats. We can't bias the results. We can't try and fix the results to show the outcome that we're looking for. Okay, so I've been outside and I've done some quadrat sampling just looking at clover. I did 10 quadrats and 2 of the quadrats didn't have any clover at all, but I still include those when I'm calculating my mean, okay? So I've added up quadrats 1 to 10 and the total was 314. And because I did 10 quadrats in total, I divided that by 10 to get an average mean of 31.4 clover per quadrat. To work out the estimate, I need to use this equation. The estimate number is the mean multiplied by the area of the field. Now I have to multiply by 4 as well, and if this was an exam question, you'd have to be careful with this, because if your quadrat is 1 metre squared, then you won't need to multiply by 4. But because my quadrat is effectively only 1/4 metre squared, I can fit 4 of my quadrat into 1 metre squared, so I've had to multiply it by 4 for that to work with the area. Okay, so I have my 31.4, I multiplied it by the area, and then I multiplied it by 4, and that gave me that huge number. Okay, what is that? 5,866,022 clovers in the whole field. Hope you found that useful. Thank you.